Brute force approach would be to simply check every item until we find a target in a list, but if you want your program to run faster than a garden snail, you need a more sophisticated approach like divide and conquer. For example, in binary search, you repeatedly check the middle element to see on which side the target is and keep searching in that half until you find it. Declarative programming describes what the code does, but not how exactly the computer should do it, whereas imperative programming explicitly describes how the computer should achieve a result with detailed instructions. An extension of imperative programming is object-oriented programming, where you can define classes as blueprints for objects, which are single units consisting of data in the form of properties and behaviors in the form of methods. To code a class, you begin by defining the properties as variables and the methods as functions. After encapsulating properties and methods in a class, you can instantiate an object and use the dot notation to work with its properties and methods. Classes make it easy to organize and reuse code because you can define subclasses that inherit properties and behaviors of a superclass but can also extend and override them. For example, a rubber duck subclass might implement quack with a squeak instead. As a result, rubber ducks can be treated as objects of the duck class but behave differently when quack is called, which is the concept of polymorphism.